This is an introduction to inequalities. So we'll use a scale. I've drawn a scale here to help us understand what's happening and unpick the rules. So on a scale, when it is balanced, we'd have an equation that both sides be equal to each other. Whereas when it comes to inequalities, we're talking about one of them being heavier than the other. In this case, the two apples weigh more than a pear. So what we're going to write here is 2a is greater than a pear. What do you think is going to happen if I add on both sides? Just like so. This side will still remain heavier because we've added the same amount on both sides. In order for them to be balanced, I need to add more on this side, which I haven't done. So adding the same amount on both sides will keep the inequality the same. Even if I add 2 on each side, 3, 4, 5, 100, but they've got to be of the same weight because we're talking about weight in this particular case. Sometimes we might talk about price, so that's what you need to focus on. So if I take away the same amount both sides, let's take away an apple on each side, the inequality will not change. What if I multiply? So I'm going to double both sides. Still, the inequality sign will remain the same because this will be even heavier now. So if we multiply by the same number both sides, you'd keep the inequality the same. We'll have a look at negative numbers in a second as well, and let's see whether that is still applicable. But we're working with positive numbers, and that's what we're getting. So I could multiply by 3, 5, 6, 100. As long as I multiply both sides by the same number, it should keep the inequality the same. What if we divide? So I'm going to halve these, going back a step. And still the inequality remains the same. Now we'll look at each and every one of these through some examples. So 3 add 3 is greater than 5. If I add the same amount on both sides, so if I add 2 both sides, I'll end up with 3 add 3 add 2 being greater than 5 add 2. So that is 6 add 2, which is 8, being greater than 7. And that is true, so it's working. What if I add a negative number? So 3 add 3 add negative 2. Which is in fact the same as subtracting. So 3 add 3 is 6, take away 2 gives me 4, 5, take away 2 gives me 3. That still is working because 4 is greater than 3. So we've proven that these two are working. But what if we multiply? So let's multiply them by 2. So 2 times 3 add 3 is greater than 2 times 5. 3 add 3 is 6. 2 times 6 is 12. Is that greater than 10? That's right, it's working. But what if we multiply it by a negative number? So if I multiply 6 by negative 2, it gives me negative 12. And if I multiply negative 2 by 5, it gives me negative 10. Is negative 12 greater than negative 10? No, it's not. So we'd have to change the sign. So this works with positive numbers, but it doesn't work with negative numbers. When you multiply by a negative number, even if you multiply both sides, you'd need to change the sign, just like we did here. From a greater than, we change it to a less than. Is it the same with division? So let's divide them by negative 2. So 3 add 3 divided by negative 2 is greater than 5 divided by negative 2. 6 divided by negative 2 gives us negative 3. 5 divided by negative 2 gives us negative 2.5. Is that greater? No, it's not. So we've got to change the sign. So again, with the division as well, it works with positive numbers. It stays the same. The sign stays the same if you multiply both sides by the same number when that is positive. When it's negative, you've got to change the sign.